Hello students. Uh, for the coming exam, okay, you have exam those who have not achieved good score, okay, good grades in IBDP, AAHL. For them, I am going to put lessons, 32 lessons in 32 hours. I am going to complete the whole syllabus, okay, all important things in this AAHL course, okay, which are required for the exam. My aim is, look here, this is your timetable, right? This is the timetable. You are going to have maths paper 1 HL and SL of 2 hours. This is 1 hour 30 minutes on 30th of November, and on 31st of November you have both the papers, paper 2 as well as paper 3. Paper 2 of 2 hours followed by paper 1 of 1 hour on the same day, 31st of October, right? So for this exam I have decided that I am going to give you 32 lectures, 32 lessons, approximately 1 hour each. Maybe sometimes it will be little more. Therefore, I am going to complete the whole syllabus in 32 hours, including past papers and some important questions from his book. Okay, I am going to follow his book, blue and green. You know that you have those two books, and all important questions from the Heath book and all important questions from the past paper. I am going to explain it to you, okay, in detail. So please be with me. Maybe some days I'll put 2 lessons and some days 1 lesson. It depends on my availability, because I teach to some other students as well as I have to record these videos for the YouTube. I will try to put each video every day at 10 o'clock in the morning, and if there is another video on the same day, I'll try to put it at say 4 or 5, between 4 and 5 each day, PM, I mean in the evening. Okay, so let us start. Wish you best of luck, right? Be with me and try to solve further more questions as we follow this curriculum, right? Okay then. So look here, this was about your timetable. Your first exam, paper 1, is on 30th of October. Second and third papers, both of them are on 30th of they are, paper 2 and paper 3 are on 31st of October. Okay, so this is lesson 1. Your syllabus is something like that. Topic 1, I am going to cover 5 hours. Okay, these are by IBO, but this is by me. Okay, this one is by me. This I have planned it to complete in these many hours, right? So number and algebra, which comes under topic 1. This is topic 1. I'll complete in 5 lessons, each of 1 hour. Topic 2, functions, I'll try to cover in 4 hours. Topic 3, geometry and trigonometry, I'll try to cover in 7 hours, because there will be 3-dimensional geometry, and in trigonometry also there are so many things. Okay, so I have put 7 hours. I have kept proportionate to this, okay, from AAHL. Okay, this is, of course, I am going to cover AAHL. This is from your AAHL syllabus, right? Okay, then topic 4, statistics and probability, I will cover in 5 hours, and calculus, topic 5, I will cover in 7 hours. This you can keep for development and investigation skill, but I hope you must have completed this. So maybe I'll get 4 more hours for completing these 5 topics. This I'm going to omit it. Okay, so maybe I'll explain it to you in more detail. Okay, maybe I'll increase 1 more lesson in functions, and 2 more lessons here. Okay, and 1 more lesson here I am going to add. Okay, let me put it here itself, 1 more lesson here. Then geometry, I will need 2 more lessons, and calculus, I'll add 1 more lesson. I'll cancel this because this is your internal marks. Okay, so like that I'm going to complete 32 hours, right? Okay, so your papers are like this. Also, let us see the papers. No technology, you cannot use GDC. Okay, I'm using this calculator. If you like, if you want me to use TI and Aspire as well as along with this calculator, please write it in the comments. Also, you can put questions in the comment, your doubts, any past paper questions. I'll try to answer all your papers. Okay, I am going to give you my email ID as well as my WhatsApp number, so you can contact me anytime, and I will be okay, I'll reply your doubts. So let me know which calculator you want me to use, because I like this calculator, Casio CG50. Okay then. So this is paper 1. You cannot use the calculator. Section A, compulsory short response questions based on syllabus. Section B, compulsory extended response, okay, questions based on the syllabus, and this will be, HL will be 30%, right? 2 hours exam for HL. Okay, then paper 2 will be with the GDC. Okay, you can use GDC here. Section A will have compulsory short response questions, and section B will have compulsory extended response questions, and for both of them you will need GDC. Okay, this will be covering 30% of your marks. Then paper 3, same day, it is on 31st of October. I hope you remember it. Okay, let me put it here. October 30th, this exam. October 31st, this exam, as well as this exam, October 31st. Okay, both the exams are on the same day. So this paper will be really, you will have to work for this paper 3, because it is together with paper 2. So be careful about it. So you can use technology. 2 compulsory extended response, okay, problem solving questions. There will be 2 questions. Okay, that will cover 20% of your percentage mark, right? And it will be of 1 hour. This will be of 2 hours. This will also be of 2 hours. Okay, then. So let us start now. Look at this. This is sequences and series. According to your syllabus, operation with A multiplied by 10 to the power k. It means indices and all. So I thought, let me give you rapid revision of the basic things. So natural numbers. I hope you know the natural numbers. In short, we can call them counting numbers, but they start with 0, 0, 1, 2, 3, 4, and so on. The set of natural numbers is denoted by capital N. Okay, and this is an infinite set, of course, because this is unending. Okay, you can have any thousands and 100,000 and so on, right? Okay, now factors. What are factors? Factors of a natural number are all the natural numbers which divide exactly into it, leaving no remainder. Okay, when we divide, for example, here when we divide 10 by 1, there is no remainder, of course, 10. When we divide 10 by 2, there will be no remainder, 5. When we divide 10 by 5, there is no remainder, so 2. When we divide 10 by 10, we get 1 and no remainder. That is the meaning of this, that factors. So let us see some other factors also. Okay, some other factors. What do you think? What can be the other factors? Okay, let me put, for example, the other factors can be factors of 12. Let us see. Okay, factors of 12. Can anyone tell me factors of 12? The factors of 12 are 1, 2, 3, 4, 6 and 12, right? So if you divide 12 by 1, 12 by 2, 12 by 3, 12 by 4, 12 by 6 and 12 by 12, there will be no remainder. Similarly, you can write factors of, let us call it Factors of 30. So what are the factors of 30? Can anyone tell me? Yeah, 1, definitely 1 is factor of every number, then 2, then 3, because 30 can be divided by 3, then 5, of course, next. Also 6 is there, 6 5s are 30, then 10, 10 3s are 30, and 15, 15 2s are 30, and of course the last one is itself. Okay, so I hope you understood factors. Okay, then multiples. Multiple of any natural number is obtained by multiplying it by another natural number. So for example, multiples of 3 are 3. 3 times 2 6, 3 times 3 9, 3 times 4 12, 3 times 5 15, 3 times 6 18, right? So in this way we can write furthermore some other multiples. So for example, multiples of, let us call 5. So what are the multiples of 5? We start with 5. 5, 10, 15, 20, 25, 30, and so on, isn't it? Similarly, multiples of, let us write for 6. What are the multiples of 6? Start with 6. 6, then 12, then 18, then 6 4s are 24, and so on. Okay, 6 5s are 30, of course, 6 6 are 36, and so on you can have, right? Okay, now let us see integers. Integers, you already know, integers are negative and positive numbers with 0. Okay, there will be no fraction, of course, in integers. Integers can be represented by the number line, right? So on the number line we can write 0 in the middle, then negative numbers on the left, negatives are on the left, positives are on the right. And then from this order you can understand that the numbers on the left are less than numbers on the right. They are less. Okay, any number on the left is less than any number on the right. Okay, so integers include negative integers, 0, and positive integers. 0 is neither a positive nor a negative integer. Okay, 0 is in the middle of negative and positive integers. So if you have to write z plus, see, we denote this z by, denoted by z, capital Z, of course. Okay, then this section will be denoted by z minus, this section will be denoted by z plus, isn't it? Positive integers, negative integers. 0 doesn't get included into negative integers or positive integers. The 0 is in the middle of both types of integers. Okay, so let us see that property I told you just now. Okay, so for example, if you choose any two integers, this one and suppose this one, so which is on the left? This is on the left, therefore this will be less than the number on the right. So therefore negative 4 is less than negative 1. This is the order between them. In the same way you can choose 1 and 5. Okay, 1 and 5. So 1 is on the left, so there definitely it will be less than the number on the right. So therefore 1 is less than the number on the right is what? 5. In the same way, of course, you can choose negative and positive as well. So this is negative 3, this is positive 4, right? So negative 3 is on the left, therefore it will be less, right? So negative 3 is less than 4, positive 4. So this type of relationship is there between the number line, between the numbers on the left and the numbers on the right. So of course, I hope you understood basic thing. Okay, now look here. Here is the index notation which was given in the syllabus. So 2 to the power 3, what is the meaning of 2 to the power 3? So 2 to the power 3, okay, 2 to the power 3 we can write as 2 into 2 into 2, of course, so 8. Okay, in the same way 5 to the power 4, you can write 5 into 5 into 5 into 5, which will be 5 5 is a 25, 25 25 is a 625. So how many factors will be there? 4 factors. Okay, 4 factors will be there because the power is 4. Similarly, if power is n, there will be n factors. Okay, so I hope you understood this also. Then let us see the syllabus. You have this syllabus, arithmetic and arithmetic sequence and series, use of formula, nth term. We will see that formula. It is going to come. First n terms, the formula for the first n terms. I will tell you the meaning of first n. What is the meaning of first n? Then use of sigma notation, of course. This will come in series. Application of it, we will see application also. Analysis, interpretation, prediction where model is not perfectly arithmetic in real life. Okay, then. So let us see what is there in your syllabus. This is from the blue book I have chosen. Okay, this is from blue book. Okay, so number sequence is there, then arithmetic sequence is there, then geometric sequence is there, growth and decay. We will discuss this growth and decay. Financial mathematics series, arithmetic series, finite geometric series and infinite geometric series. All these things are there. 1 2 3 4 5 6 7 8 9. 9 sections are there. So I think in this section, in this lesson, I mean the first hour, I am going to cover only these things and together with arithmetic series. Okay, lesson 1. Then in lesson 2, I'll try to cover the past paper questions because I checked, I was unable to cover past paper in this first lesson. No problem. In the second lesson and preceding lessons, we are going to cover past paper questions. Okay, so let us see what is there. First part, number sequence. Okay, you already know what is the meaning of number sequence. Any sequence which has certain order, okay, between the consecutive terms. Consecutive means one after the other. That is called a sequence. Okay, so let us see. For example, number 1, 2, 5, 8, 11 and so on. So you know that add 3 in the previous term, you get the next term. Add 3, you get the next term for next term. Okay, right. Similarly, we can see another type of number sequence which can be 3, then multiply by 2, 6, multiply by 2, 12, multiply by 2, 24 and so on. So multiply by 2. Multiply by 2 for next term, right? Yeah. So these are simple number sequences. Now, of course, in your syllabus there will be arithmetic sequence. So, but this is a general number sequence, right? Okay. Look at this general term of a sequence. There can be a general term. You can define a formula in terms of n, in terms of k also, whatever you like. Of course, in your GDC you have to use x, but in NSPIRE you can use n, no problem. Okay. In this one you cannot use any other letter for the formula, you have to use x. Okay. So Tn, Un, Tn, small tn or capital An or whatever you like will be representing the nth term. Okay, and this in parenthesis Un represents the sequence. Okay, sometimes it can be in rectangular brackets. Okay, like this Un, no problem. So that generates using Un, the nth term. If your nth term is Un, you can write the sequence like this, Un, right? Okay. Let us go to the next page. Look here, consider the number sequence minus 9, minus 6, minus 1, 6, 15. Okay, this is a given sequence. Now the question says, which of these is the correct explicit formula for this sequence? Okay, which is the correct explicit formula? So let us see formula 1. Okay, I mean A says in this answer I'll write un is n minus 10. So let us check. U1 will be 1 minus 10, which will be minus 9. U2 will be 2 minus 10, which will be minus 8. So of course this doesn't satisfy even the second term, because the second term is minus 6, but we are getting minus 10. So this cannot be the formula for this sequence. So let us check now B, the formula B. Un is n square minus 10. So what will be the terms? U1, replace n by 1. So 1 square minus 10, 1 square is 1 minus 10 is minus 9, that is correct. Okay, this is correct. Then U2, 2 square minus 10, 4 minus 10, which will be minus 6. So it seems to be correct. Okay, let us check one more term, U3. 3 square minus 10, 3 square 9 minus 10 will be minus 1. So even this is correct. So it means this sequence, this formula seems to be the correct formula. So therefore it is represented by B. Okay, use the correct formula. Now it says correct formula to find the 20th term. So this is the correct formula. This is the correct formula. So therefore let us find part B. This was part A. In part B we have to write the formula and then substitute replace n by 20. So let me choose another color. Un is n square minus 10. So therefore U20 will be 20 square minus 10. 20 square is 400 minus 10. So 390 will be the answer for U20. Okay, I hope you understood. This was simple. Now arithmetic sequence. Okay, what is arithmetic sequence? Arithmetic sequence is a sequence where there is a constant difference. Constant difference is called common difference, denoted by D. Okay, so if a sequence is arithmetic, it implies un plus 1 minus un will be D. Means, see, un plus 1 means next term, and un with respect to un plus 1 is previous term. Okay, so next term minus previous term should give you D. Sometimes students take the first term minus the second term. That is wrong. There will be difference of sign, minus sign. Okay, so always choose the second term minus the first term, right? So let us see here. Second term here is 5. 5 minus 2, it is 3. 8 minus 5, it is 3. 11 minus 8, it is 3. So common difference is 3. Therefore this is arithmetic sequence. Arithmetic sequence, right? A sequence can also be called as arithmetic progressions. Some books write it AP. Okay, now let us check second sequence whether it is arithmetic or not. So 25 minus 30, so minus 5. 20 minus 25, second term, next term minus the previous term. I am taking second minus first, third minus second, fourth minus third, and so on. So it will also be minus 5. Then third term is I have taken fourth term, 15 minus 20, again it is negative 5. So therefore there is a constant difference, which is D is equal to negative 5. Hence it is also arithmetic sequence, right? Okay, this was also easy. So I hope you understood this, right? Let us see the next page. Here the general formula for the nth term is given. This is also given in the formula booklet. Okay, formula booklet. This formula is there. So no need to memorize it. But I expect that you know these formulas, because for every simple thing, if you refer to the formula booklet, maybe you will spend time in that and time will not be sufficient for you. So you should save the time also. Okay, so this is the formula for the nth term or the general term, un. u1 the first term plus n minus 1 d. Okay, so in this formula u1 is the first term, okay, and d is the common difference, right? So, and n will be any term, whatever term you have. Now look here, one more thing you should understand, that in this formula there is n minus 1. So d is 1 less than the term number, 1 less than term number. So if term is third, so u3 will have u1 plus 2d, u4 will have u1 plus 3d, and so on. D will be 1 less than the term number. Okay, so I hope you will remember it. Okay, because this will be very helpful for you. Okay, so let us see this question from exercise 5b. Okay, I started from 5b.1, question number 3, of course from the blue book. Okay, so this question says, consider the sequence 87, 83, 79, 75, 71. Show that the sequence is arithmetic. So this is the first part, and I hope you already know about it. So second term minus the first term, 83 minus 87, which will be negative 4, 79 minus 83, again it will be negative 4, and 75 minus 79, again negative 4, and 71 minus 75 will again be negative 4. So therefore D is negative 4, hence it is arithmetic sequence, right? Yeah, the question asked whether it is arithmetic sequence or not. Now B part says, okay, it says find the formula for its general term. Okay, now you already know the formula for the general term, un is equal to u1 plus n minus 1 d. So based on this formula, let us see what all are given to us. Is u1 given to us? Yes, u1 is the first term, 87. Okay, is d given to us? Yes, d is also given to us. What is d? D is negative 4. So d is equal to negative 4. Let us put it in the formula. So therefore un is u1 means 87 plus n minus 1, d is negative 4. And when you simplify this, negative 4 into negative 1 will be positive 4. Positive 4 plus 87. So 87 plus positive 4 will be 91. So 91 minus 4n. Okay, negative 4 multiplied by n, negative 4n. This becomes the formula for the general term. Okay, okay then. So then C part, what they are asking? They are asking find the 40th term. So simple thing, replace n by 40. So therefore u40 is 91 minus 4 times 40. 4 times 40 is 160. So negative 160. When you simplify this, 91 minus 160 gives you minus 69. Of course you have to do it manually. So I hope you can do it directly also. So this is the answer. Okay, minus 69. Okay then. Let us now D part is also there. What is D part? Let me write in red color in between this, because there is no space. I have chosen a 16 by 9 slide. Okay, so D part I am going to write here, no problem. I hope you will understand it. So D part says when terms of the which term of the sequence is minus 29, minus 297. Okay, so let me write here un is minus 297. So therefore minus 297. We will put it the right hand side of it here. 91 minus 4n. Take 4n there, bring 297 here. So 4n, okay, is equal to, let me erase the other things. 4n is equal to 91 plus 297, and then we will divide by 4. So let me add these things. So 91 plus 297, okay, 388, okay, divided by 4 gives you 97. So the term is 97, 97th term. So n is equal to 97, okay. 97th term is minus 297. So I hope you understood this. Let us see the next question. Suppose 10k plus 1, 2k and 4k square minus 5 are consecutive terms, means one after the other, of arithmetic sequence. Find the possible value of k. Because it is arithmetic sequence, so difference between the consecutive terms should be constant. Okay. So let us start A part. Second term minus first term, 2k minus 10k plus 1. This will be same as the third term, 4k square minus 5 minus the second term, 2k. Okay, so let me show you. This minus this, so I wrote it here, this minus this, and then this minus this. So 4k square minus 5 minus 2k. Okay, so now we'll simplify this. So 2k minus 10k minus 1, we open with negative sign, is equal to 4k square minus 5 minus 2k. Now 4k square will keep there, take the 2k also there and 10k also there. So 2 minus 10k will be 8k, which will be positive 8k there. So 4k square, okay, and minus, look here, these two together gives you minus 8k. When I will take it there, it will be plus 8k. So 2k minus 2k plus 8k will give me 6k on the left hand side. I am going to write that on the right hand side, of course. So 4k square plus 6k. Then 5, I'll also bring this minus 1 here. So it will be minus 5 plus 1. Minus 5 plus 1 will give me minus 4. Okay, so minus 4 is equal to 0. I can divide by 2, or I'll keep it like that. Because using GDC I can find. Here you can use GDC, or let us see manually also how can you do. I'll show you the GDC method. So I'll divide by 2, right? So 2k square plus 3k minus 2 is equal to 0. 2 times 2, 4. Look here, multiplication of first and the last term is negative 4. Now how can we write this 3? We can write 4k minus k. When you multiply these two, it will give you this, and when you add these two, it will give you plus 3k. I hope you understood. So plus 4k and minus k will give you the we split the middle term into two parts. 2k square plus 4k minus k minus 2 is equal to 0. Make pairs, take out common. So 2k into bracket k plus 2 minus 1 only common, so k plus 2, and this will give you k plus 2 and 2k minus 1, of course equal to 0. So therefore one value of k is negative 2, the other value is half, right? Negative 2 and half. These are the two values of k. Okay, these are the two values of k, right? So we got the two values of k. Now what we have to do? Look here, you can find this using GDC also. I'll show you where you have to go. Suppose if it appears in paper 2 or paper 3, go to menu, okay, in menu, right, go to equations, it is A in this, okay, this is equation. From equation you have to choose second because it is polynomial, so F2, right, F2. In F2, now which type of polynomial? Of degree 2. So we have to choose degree, which is F1, degree 2. Now look here, it looks like this. Now here you have to put, I have divided by 2, so first one will be 2, then 4, then negative 2, right? Yeah. Now what are my factors? Let me go back. What I have put? 2, then 3, sorry. 3 I should have put. Then negative 4 is correct. So look here, these are my factors, okay? 0.5 and negative 2. First is half, and second, if I bring my cursor to the second place, it will be negative 2, okay? So first one is half, second one is negative 2. So therefore, I got both the things. So just I have shown you using GDC, right? If it appears in paper 2. Now B part of this question says, what it says, for each of the values of k, find the common difference of this sequence, okay? So for k is equal to negative 2, okay? For k is equal to negative 2, what we have to find? The common difference D. Okay, so what will be D? Any part you can choose from here. This also can give you D, or this also can give you D, but we will not take this because there is a square. Let us choose this. Okay, so D is 2k minus 10k plus 1. Replace k by negative 2, here negative 2, here negative 2. So that will give us D is equal to 2 into negative 2 minus 10 into negative 2 plus 1. When we simplify this, negative 4 and this together gives you negative 20 plus 1, negative 19, positive 19. 19 minus 4, it will be 15. So D is equal to 15 for the first k, okay, negative 15, positive 15 of course, sorry, I should go here and give you this, right? Now for k is equal to half, so again we will choose the same formula from here. So D is equal to 2k, k means half, minus 10 into half plus 1. 10 into half gives you 5, 5 and 1, 6. So minus 6. 2 multiplied by half gives you 1. So 1 minus 6 gives you minus 5. So therefore D is equal to minus 5. Okay. So I will highlight it by this, right? Okay. So therefore this is the second D for second k. K is equal to that, right? Let me erase this part. I had highlighted this by mistake. Okay. So now it looks good, right? Okay. Next question now. See, the question number 10, B.1. I have chosen some questions from this exercise which are different, okay? So that you learn the techniques, right? Okay then. So A part says, what the question says, find the general term un for arithmetic sequence with 7th term 41, 13th term 17. Let us do part A here. So U7 is 41. U7 is 41 means how can we write U7? Let me write the formula here for your reference. Un is U1 plus n minus 1 D, isn't it? Yeah, this is the formula. So U7 means U1 plus 6D, because D is 1 less than the term number, I told you already. So 7th term will have 1 less D, okay? Right. And this is equal to what? 41. This is equation 1. Then U13 is 77, which means U13 means U1 plus 12D. Remember that D is 1 less than the term number. So our term number is 13, therefore D will be 1 less means 12D, right? and this is equal to 77. This is second equation. We are going to solve these two equations, right? So to solve these two equations, we will subtract them. So let me change the sign of the second equation, right? So negative, negative, negative. When I subtract, this is going to get cancelled. U1 and U1, positive and negative U1. 6 minus 12 will be minus 6D. 41 minus 77, so 77 minus 41, 7 minus 1, 6, 7 minus 4, 3. So minus 36. Therefore, D is equal to, divide by negative 6, so negative and negative, positive, 6 will be the answer. So D is 6, so we got D, right? So what we have to find? Find the general term. So D we found, now we have to find U1. So therefore from 1, U1 plus 6D, D is 6 itself, is equal to 41, 6 6 is 36, so U1 is 41 minus 36. How much it will be? 5, right? So therefore U1 is 5. So we got U1, we got D, therefore we can write the general term. Therefore UN, general term, the formula already I wrote here. So UN is equal to U1 means 5 plus n minus 1. We have to keep n as it is. D is 6. So after you simplify, 6n minus 6. So 5. Let me write the general term. UN is equal to 6n, because 6 multiplied by n, 6n. Then 5 and minus 6. 5 minus 6, minus 1 will be there. So 6n minus 1. This is the general term, right? UN. UN is called the general term, right? Now part B, we will do on the next page. Let me copy it. Okay. It is already copied. Okay, good thing. So again, we will continue in the same way, okay, as we did earlier. So U5 is negative 2. It means U1 plus how many D? 4D. Please remember it, because D is 1 less than the term number. I am repeating, U5 will have 4D, right? Okay. And this is equal to negative 2. This is equation 1. Similarly, second equation is U12 is equal to minus 12 and half. So it will be U1 plus how many D? 11D, because here U12, 12th term will have 11D. So 11D is equal to negative 12.5. Let me write. So second equation, right? Okay. Now again we will subtract them like the previous question. So negative, negative, positive. We will change the sign because we are subtracting. Okay. We can write also here 1 minus 2 gives. Let me write it there also. 1 minus 2 gives. And it is here, of course. Okay. So U1 and U1 cancel. 4 minus 11, right? How many D will remain? Minus 7D, because 7 and 4, 11, right? So minus 7D is equal to plus 12.5 minus 2, so 10.5 positive. Okay, you have to divide by negative 7. So D will be 10.5 divided by negative 7 will give me negative 1.5. This is D, right? Okay, so I got D. Now I have to find U1. So like previous question, from equation 1 I will write U1 plus 4D. D we have now negative 1.5 is equal to what? Negative 2. From this equation I am choosing. Okay. U1 we have to find. 4D, D we already have, and is equal to negative 2 we already have. Okay. So here 4 times negative 1.5 my negative 6. Okay, so u1 minus 6 is equal to negative 2. Take negative 6 there, so it will be positive 6. Positive 6 minus 2 will give you 4. So I got u1 also. Now after finding both of them, I can write the general term. Again let me write the general term here. un is equal to u1 plus n minus 1 times d. Okay, so therefore the general term will be un is equal to u1 4 plus n minus 1 times d. D is negative 1.5, right? So therefore this implies, see, this will be negative 1.5n and negative positive 1.5, and this positive 4. So 4 plus 1.5, 5.5. Okay, so therefore un will be 5.5, because 4 and 1.5, 5.5 minus 1.5 n. So this is the answer, right? Okay, I hope you understood this. Okay, let me highlight it. Yeah, let us see what is next. Yeah, here, from here, geometric sequence is there. See, geometric sequence. So we will have a geometric sequence. We will use the geometric sequence formula, which will follow on the next pages. Then the nth term, like the previous one, nth term of the geometric sequence, and then application. Of course, application we will take at the end. Maybe in the next lesson I will cover application of both arithmetic and geometric sequences and series, and then the past paper questions. Okay, don't worry about it, I am with you. Okay, geometric sequence. Geometric sequence where there is a constant ratio. So see, again here un plus 1. Un plus 1 means next term divided by un means previous term. So next term divided by the previous term gives you r, the common ratio. Okay, so let us see here also. See, 2, 10, 50, 20, 250. So see, 10 divided by 2, 10 divided by 2, 5. Then 50 divided by 2, 10, 5 again. Then 250 divided by 50, 5. So 5 is the common ratio. Like arithmetic sequence, in arithmetic sequence there is always a constant difference or common difference. Second term minus first term, same as third term minus second term, same as fourth term minus third term. In the same way, in geometric sequence, second term divided by first term is same as third term divided by second term, is same as fourth term divided by third term, which will be equal to r, the common ratio. Okay, then the formula is like this. un is u1 into r raised to n minus 1. N will be 1 less than the term number, because look here, I'll show you why it is 1 less. See, if you have the terms, so first term is always u1, second term will be multiplied by r. So see, r will have power 1, third term will be multiplied by further r, so 2, fourth term u1 multiplied by next r again. So see, again here second term will have 1 power of r. Okay, third term will have 2 powers of r, fourth term will have 3 powers of r. So again, like the arithmetic sequence, in arithmetic sequence d is 1 less than the term number. In the same way here, r, the power of r is 1 less than the term number. So if it is second term, power of r is 1, third term, power of r is 2, fourth term, power of r is 3, and so on. u1 will be multiple of each term, of course. Okay, okay, then let us see the next thing now. Okay, yeah, you know that here u1 is the first term, of course. u1 here, let me write again like the arithmetic sequence. I didn't feel like writing. u1 first term and r common ratio. Okay. Okay then. So let us see the exercise. The first question says, show that the sequence is geometric. See, like arithmetic sequence. In arithmetic, what we did, second term minus first term, third term minus second term, fourth term minus third term, they are all D. Okay, like that in geometric sequence, second term divided by first is same as third term divided by second, third term divided by second term, fourth term divided by third term. Okay, so let us see here A, part A. Okay, so we have to check whether it is geometric sequence or not. Okay, so 10 divided by 5 is 2, 20 divided by 10 is 2, 40 divided by 20 is 2. So therefore all of them are 2, hence it is geometric sequence, right? Okay, now B part says find UN and also find the 15th term. So first term is 5 and as we have seen R is 2. Okay, now we have to write the general terms. The formula says UN is U1 into R raised to n minus 1, right? Okay, so therefore we will write UN is equal to U1 means 5, R is 2, 2 raised to n minus 1. This becomes the general formula. And from this formula we have to find U15. So therefore U15, replace n by 15. 5 into 2 raised to 15 minus 1. So 5 into 2 raised to 14. Of course you will need calculator here. So 5 into 2 raised to 14 I have to find. So it is 81920. Okay. So this is the answer for this. Let me highlight it. Okay, let us see the next question. Okay, next question says, for the first 3 terms of the geometric sequence are these: first term, second term, third term. You know that what is the property of the geometric sequence. Second term divided by the first term should be same as third term divided by the second term. And from that we are going to get the possible values of k, because we will get 2 values of k. Okay, so let us see here. Second term is 6 divided by first term k minus 1 is equal to third term 3k divided by second term 6. Now cross multiply. This will go here, this will go here. So 36 is equal to 3k into k minus 1, right? So 36 is equal to 3k square minus 3, right? Okay, minus 3k, sorry. Okay, now we will simplify this. Take the 36 also there. So 3k square minus 3k minus 36 is equal to 0. Divide by 3. So k square minus k minus 3 1s are 3, 3 2s are 6, 12. So 12 means 4 3s are 12, negative 4, positive 3, right? So k minus 4, k plus 3. Manually I am doing. Of course you can use GDC and find the factors. So those will be the values of k. So k is 4 and k is negative 3. These are the 2 possible values of k, of course. Okay, so we got the answer. K is equal to 4, k is equal to negative 3. Now the second part of it says, B part, for each value of k find the next term. Only the next term we have to find. So for k is equal to negative 3, I will choose first. Okay, k is equal to negative 3. First term is k is equal to negative 3, so we will put it here. So negative, sorry, let me write it properly, negative 3. So negative 3, negative 1, so it will be negative 4 first term. Okay, second term 6 already is the given here. And third term 3 times negative k will be negative 3 3s are 9, negative 9. Okay, now the next term will be what? So let us find r from this, then only you can find the next term. So r will be what? 6 divided by negative 4, which will be negative 3 divided by 2. R is negative 3 divided by 2. So therefore next term will be 3k, the third term was negative 9 multiplied by negative 3 by 2. So negative and negative positive, 27 by 2. This is the next term. Okay. Now for the next k, see, first k was this. For this we found it. Now for k is equal to 4. Okay. For k is equal to 4, let us find the terms. First term will be 4 minus 1, 3. Next term is 6 already. Next term is 3 times 4, 12. So r will be what? 6 divided by 3, 2. So next term will be what? Therefore next term means after 12. So next term will be 12 multiplied by 2, which will be 24. So this is the next term when k is 4. Okay. I hope you understood this also. Now let us see the next question. Okay. This question says find the general term, right? Okay. Find the general term un of the geometric sequence, right, which has u4 24. So let me write here a part. u4 is 24. So therefore u4 means u1 into r raised to 3, because term is 4. So power of r will be 3, is equal to 24, first equation. And u7, right, u7 is 192. So u1, and what power of r will be there? It is 7th term, so 6 power. Okay, 1 less power, like the arithmetic sequence, 1 less, is equal to 192, second equation. So second equation divided by first equation gives, okay, we'll divide second equation by first equation. So u1 r raised to 6 divided by u1 r raised to 3 is equal to 192 divided by 24. So here u1 and u1 will cancel, 3 will go up, right? 6 minus 3, 3. So r raised to 3 here is equal to 192 divided by 24. 192 divided by 24 gives me 8. So r cube is 8. Therefore r is equal to 2. We got the value of r, right? Let me highlight this. Now we'll put it in the first equation. From 1 u1 r raised to 3, right? Here r raised to 3 we have, right? So r raised to 3 means 2 raised to 3 is equal to 24. 2 raised to 3 is 8. So u1 is 24 divided by 8. So 3. So first term is 3. Okay, let me highlight this. First term is 3, right? Now what we have to find? So let me put one line here. Okay, therefore general term is un u1 r raised to n minus 1. u1 is what? 3. R is what? 2 raised to n minus 1. It will remain as it is. So un is this. This is the general term, right? Okay. Okay. So we have found this. Now B part I think we'll do on the next page. u3 is 8 and u6 is minus 1. Okay. Like the previous question, u3 is 8. This implies u1 r raised to 2. See, again it is third term. So what will be the power of r? 2. Okay. Third term will have power 2. Then sixth term will have power 5. 1 less, is equal to 8. And this is equation 1. and u6 is minus 1, right? u6 is minus 1. So u1 r raised to 5, right? u1 r raised to 5 is how much? Negative 1, second equation. Now second equation divided by the first equation gives u1 r raised to 5 divided by u1 r raised to 2 is negative 1 divided by 8. u1 and u1 will cancel, of course. 2 will go up, and minus 5 minus 2, 3. Okay, so u r raised to 3 is minus 1 by 2 to the power 3, right? 1 by 8 is 1 by 2 cubed. So therefore r is equal to negative 1 by 2. So we got the value of r, right? Let me highlight this. And now we will find the value of u1. So from equation 1, from 1, u1 r is negative half square is 8. Half square will be 1 by 4 positive. u1 1 by 4 will go there. 4 8 times 4. So 32. So u1 is 32. So we got u1, right? Let us highlight this. So u1 is 32. Now general term. Therefore general term is un, which will be u1 r raised to n minus 1. u1 is what? 32. r is what? Negative half to the power n minus 1. That's it. This is un, right? Okay. So this is the general term. I hope you understood all this, right? Okay. Now series. Okay, few questions from the series also we will do. What is series actually? Series, when you add the terms of the sequence, they are called in series. Okay, for example, if you have a sequence 2, 5, 8, 11 and so on, this is sequence. When you write them with plus 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 or minus minus minus, that is called series. 2 plus 5 plus 8 plus 11 plus so on. This will be the series. Okay, this is the meaning of series. Now series will have its sum. Okay, we can add it. Now some series are finite, some are infinite. If the sequence is finite, its series is finite, and therefore its sum will be finite, and it will be called convergent series. And some series are infinite, so we cannot find the sum of it because it is infinite, right? Okay. So sigma notation. Now look here, series can be represented by sigma notation. This sigma notation is used for plus 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 plus. Okay, if there is minus, of course you can write minus minus minus, but it will be assigned a negative value for the term, so that automatically the terms will become minus. So when you have u1, u2, u3, u4, u5 and so on, okay, so u1, u2, u3, u4, un, so it can be represented in general by uk, where k is from 1 to n. So replace k by 1, you get u1, you replace k by 2, you get u2, and so on until you get the upper limit. This is called lower limit 1 and upper limit n, so un, right? And we read this as the sum of all the numbers of the form uk, where k is 1, 2, 3 up to n, right? Okay. So look here, like this I can choose any series. For example, if I have a sequence 2, 6, 18, 54 and so on, un, so I can write series. So uk, I can write the general term. What will be general term? First term is 2, common ratio is 6 divided by 2, 3, so 3 to the power k minus 1. And then if I want sum of this series, sum of this sequence, or sum of these terms, sorry, is sigma k from 1 to n 2 into 3 raised to k minus 1. That's it. This will represent the sigma sum of all these terms, okay, by sigma notation. Okay then. Now what are the properties of sigma notation? The first property is when two variables, look here, how you will identify the variable? If here the limit value is represented for k is equal to 1 to n, so k will be your variable, okay. So whichever place you have k, so that will be a variable term. So variable terms, if they are with plus into sigma notation, then you can separate them, you can split them. So first sigma notation will have ak, second sigma notation will have bk, okay. Like that you can write it. And if you have a constant term c in the sigma notation, then it can come out with, if it is with the variable, then it will come out and you can write only the variable in the sigma notation. So that will be included with the sum, okay, that will be multiple of the sum. Now if any sigma notation has only the constant, then the final answer of this sigma, I mean the sum, will be the upper limit multiplied by the constant cn. So for example, if I have sigma 5 and r, suppose r is equal to 1 to 100, then the answer of this will be 500, because 5 multiplied by 100 will be 500, okay. So I hope you will remember this, okay. Now let us see the question based on sum or sigma notation. All those things will come here, okay. So look here, for each of the following sequence, write down the expression for Sn. Sn means sum of the terms, okay, all the terms. When it is added, of course with the sigma notation you have to represent. There is another formula for Sn, but we are going to see it later on. Now here you have to express it with sigma notation, right? Okay then. So A, first part of A, u1 is 3. Now we have to identify whether this sequence is geometric or arithmetic. So let me first check the arithmetic part. 11 minus 3, 8. 19 minus 11, 8. Then 27 minus 19 will again be 8. So there is a common difference, 8. Therefore this is arithmetic. So therefore its nth term we can write u1 plus n minus 1d, right? So u1 is what? 3. u1 is 3 here. D is 8. So n minus 1 into 8. So therefore 3 plus 8n minus 8. So 8n minus 5. Minus 8 plus 3 will be minus 5. So this is un, okay. Now first part we wrote, write the expression for Sn. We have to write for Sn. So therefore Sn is equal to sigma, okay, n is equal to 1 to n. Let me write k for it, because n and n there will be confusion. So k from 1 to n, 8k minus 5. So replace k by 1, you will get the first term, plus replace k by 2, you will get the second term. So plus plus plus, so on, right? Now they want also S5. So let me find S5 also here. Let me make it straight. Okay. Second part of first A question, S5, okay. S5 means you will have to replace k by 1, k by 2, k by 3 up to 5. So k is equal to 1 to 5, 8k minus 5. So what I will do, replace k by 1, k by 2, k by 3. When I replace k by 1, I will get 8 into 1 minus 5. So 8 into 1, 8 minus 5, 3, plus replace 8k by 2. So 8 into 2, 16, 16 minus 5, 11. Okay. Then replace k by 3, so 8 3s are 24, 24 minus 5 will be 19, plus so here I took k1, k2, k3, now k4 and k5. I need 5 terms. Okay. So when I take 4, 8 times 4, 8 times 4 minus 5. So this will give me 27. And lastly, k replaced by 5. So 8 times 5 minus 5 will give me 35. So I have to add all of them. You can get sigma notation even in this Casio calculator, right? So you have to press math. Okay. In math, you can go to the next page. See, F6 next page, and F2 gives me sigma notation. See here, sigma notation, right? So I'll press F2. Now you can see sigma notation. I can put everything. Okay. Remember that I have to put with x. Okay. So 8x minus 5, and x will be from 1 to 5, and I'll directly get answer. 95 is the answer. See, directly I can guess S5. Okay, now the second one also we had to do B. I'll show you the procedure. So let us check whether it is arithmetic or geometric. Okay. So 37 minus 42. Okay. 5, negative 5, because negative number is big. Then 32 minus 37, again negative 5. Then 27 minus 32 is again negative 5. So it has a common difference, negative 5. Therefore it is arithmetic. Therefore we can write un. U1 is what? 42. Plus n minus 1, d is what? Negative 5. So we simplify this, negative 5n, 42 minus 5n plus 5. So 42 and 5, 47 minus 5n. This is the general term un. Therefore we can write Sn, sigma notation, k is equal to 1 to n, 47 minus 5 k. Okay. Now again this you can find using sigma notation of the calculator, right? So S5, again they are asking second part. S5, let me write the sigma notation again, and I will write 47 minus 5k, 47 minus 5k I cannot use, x, and then for x is equal to 1 to 5. Look here, I will press execute. 47 minus 5x, x from 1 to 5. Look here, you can see on this calci, I hope. Okay, so it is 160. Using GDC you can write. Yeah, now third part I'll keep for the homework. You try it. Okay, let us see the next question. Expand and evaluate. We have to expand and evaluate. Expand means like we wrote the sigma notation, we can expand also, no problem. So sigma k is equal to 1 to 3. From 1 to 3, 4k will be 4 into 1, 4, 4 into 2, 8, 4 into 3, 12. Okay. So 4, 8, 12. When we add 12 plus 12, 24. Okay. This answer is 24. Then B, sigma notation, k from 1 to 6, k plus 1. Okay. So 1 plus 1, 2. 2 plus 1, 3. 2 plus 1, 3. 3 plus 1, 4. 4 plus 1, 5. 5 plus 1, 6. 6 plus 1, 7. So up to 7 it will be. When you add all of them, 2 plus 3, 5 and 5, 10 and 10, 27. Okay. So sum of the second sigma notation gives you 27. Then C, sigma k from 1 to 4. 3k minus 5. I'll write the terms for this. 3 into 1 minus 5, first term, plus 3 into 2 minus 5 second term plus 3 into 3 minus 5 third term plus 3 into 4 minus 5 fourth term. So 3 ones are 3 minus 5 minus 2, 3 twos are 6 minus 5 plus 1, 3 threes are 9 minus 5 4, okay, plus 3 fours are 12 minus 5 7. When we add them, 7 and 4, 11 and 1, 12 minus 2 10. So 10 is the sum of this sigma notation, right? I'll highlight it, okay. Arithmetic series. Now like sigma, there is arithmetic series and there is geometric series, but we are going to take some questions from arithmetic series, otherwise time will be very long, okay. I don't want to extend this lesson, right? Okay, so in arithmetic series, look here, the formula is this: Sn n by 2, this is given in the formula booklet also, n by 2 into bracket u1 first term plus un, or this is the best way, you should follow this one, okay, n by 2 into bracket 2u1 plus n minus 1 times d, where u1 is the first term and d is the common difference, right? Common difference, okay. So this formula is there in the formula booklet, so no problem, you can use it. So based on this, let us see the exercise, okay. Now first question, find the sum of 7, 9, 11, 13 and so on. So let us follow the method. u1 is what? 7. d is what? 9 minus 7, 2, okay. So therefore Sn, let me write the formula, n by 2 into bracket 2u1 plus n minus 1 d, right? In this formula I am going to put everything. So n is what? 10. 10 terms are there. So 10 by 2. Here n is 10. Let me write. Into bracket 2 u1. u1 is 7 plus 10 minus 1 d. d is 2. Okay. So look here. u1 this, d is this, n is this, right? Okay. Now when we simplify 10 by 2, 5. Oh, sorry, u1 I should write 7 only. Okay. So 7, 10 minus 1, 9, 9 times 2, 18. So 2u1, sorry, 2u1 I should write. So 2 into 7, 14, 14 plus 9 times 2, 18. 18 and 14, 32. 32 times 5, 160. This is S10 because n is 10. So S10 is 160. I'll do B also. Let me write it here. Yeah. Okay. B, what is U1? So I hope you understand 3. What is D? D will be 7 minus 3. So 4. So therefore Sn I will write. Again I will put in the same formula. Sn, n is 20. Look here. S is 20. So S20, here S10 I should write. So S20, let me change it to 20 because n is 20. Okay. See here U1 is 3, D is 4 and n is 20. So in the formula we will put all the values 20 by 2, U1, U1 means 3, n minus 1, 20 minus 1, D is 4. Okay. 10 by 20 by 2, 10, 2 3s are 6 plus 20 minus 1, 19. 19 times 4, 76. 76 and 6, 82. So 10 times 82 will be 820. So S20 is 820. This is the answer for this question, right? Let me highlight it. Okay. So I hope you understood this question, right? Let us see. I think I'll keep it for the homework. Every question I should not do. So you try it in the homework, right? Okay. Now we will stop here. Okay. Let us end the lesson here. I hope you liked my lesson. Okay. This was the first out of 32. So 31 lessons are still remaining. 1 hour each. Some lessons will be little bit more than that, because I want to teach you past paper questions also. The type of questions which can come in the exam, which are expected. I am going to go through 4-5 years papers, and then I'll choose the best questions, okay, so that you can get prepared for that. So those types of questions or parallel type of questions will appear in the exam, I hope. Okay, so if you like my lesson, please subscribe, okay, my YouTube channel, subscribe my channel, right? Share also with your friends, okay. And if you have any doubts, so definitely you can contact me on my email ID, or you can contact me on my WhatsApp, okay. And the PDF of this explanation will be there. The link will be there in the description of this video, right? Okay. I wrote this slogan: the more you know, the more you know, the more you can follow. I mean, more you will enjoy. Okay, then, bye for now, right? Okay.